let's take a look at some problems from 10.7. You are dealt one card from a 52 card deck. Find the probability that you are not dealt a picture card. Okay, keyword here is not. Let's look at picture cards. Picture cards, we have a king, queen, and a jack. There are 4 kings in a deck. We have 4 queens in a deck and 4 jacks, which means we have 12 picture cards in a deck. And that is 12 out of a total of 52 cards. You are not dealt a picture card. So we're going to take 1, which means the whole, the entire deck, minus those picture cards, which were 12 out of 52. Let's get a common denominator. 52 over 52 minus 12 over 52 is 40 over 52. Let's reduce that fraction. We can divide numerator and denominator by 4, and we'll get 10 out of 13. Number 40, you are dealt a red 7 or a black 8. Here's our or statement. Notice you can have a red 7. There's no chance it's going to also be a black 8. So this is what we call being mutually exclusive. Red 7s. We have 4 7s in a deck of cards, but only 2 of them are going to be red. So that is 2 out of 52. Plus black 8s. Well, there's 4 8s in a deck of cards, but only 2 of them are going to be black. So that is 2 out of 52. We are down to 4 out of 52 cards. Let's reduce that. We can divide numerator and denominator by 4 again, so that is 1 out of 13. Number 42, you are dealt a 5 or a black card. Now, notice you can have a 5 that is also a black card. So this is not mutually exclusive. So 5s, we have 4 out of 52. There are 4 5s in a deck of cards, plus black cards. Well, half the deck is black, so that's 26 out of 52 cards are black. But now we don't want to count the cards that are 5 and black twice, so we need to subtract them. There are going to be 2 cards that are black and a 5 in the deck. So that is going to give us, let's see, that is 28 out of 52. Again, we can divide numerator and denominator by 4. That is going to be 7 out of 13. A single die is rolled twice. Find the probability of rolling, let's see, a 5 the first time and a 1 the second time. These are independent events. The first event is not going to affect the second event. So if we consider the first roll, a 5 the first time, well, there's only 1 out of 6 chances you're going to get a 5. Multiply it times the second event. 1 a second time. Well, again, that is going to be a 1 out of 6. This is your counting principle. It means your probability is 1 out of 36. Number 50. An odd number the first time, any number less than 3 the second time. Again, we're talking 2 different rolls, so this is going to be an independent event. So on my first roll, I want an odd number. So my choices here would be a 1, a 3, or a 5, which means I have 3 out of 6. Reduce that. So my probability of rolling an odd number is 1/2. My second event, a number less than 3. So let's go less than 3. Numbers on the die that are less than 3 are 1 and 2, which means we have 2 out of 6. Reduce that fraction, we have 1/3. So the probability of rolling a number less than 3 is 1/3. Again, your counting principle. First roll, you have a probability of 1/2. Second roll, you're going to have a probability of 1/3. Gives you a total probability of 1/6. 52. If you toss a fair coin 7 times, what is the probability of getting all tails? Well, the probability of getting a tail, you only have a choice of either a heads or tails, so that means you have a probability of 1/2. Now, if you're tossing it 7 times, well, on the first toss, it's a probability of 1/2. The second toss, it's 1/2. Third toss, 1/2, so on and so forth. And you would be multiplying your probabilities by however many times you're going to conduct that toss. So if you're tossing it 7 times, well, that's 1/2 times itself 7 times, which means you would just raise it to the 7th power. And that is 1/128.